Hello guys, welcome to my channel once again. In today's video, we are going to discuss 15 most repeated topics in physics. In my last video, I posted a JAMB syllabus, that is 2023 JAMB syllabus for physics, and majority of you guys were shouting that the topics were too much to be covered. However, from my previous experience from JAMB, I seated for JAMB 3 times. So I was pursuing all these hard courses, medicine, pharmacy, and you know how hard it is to secure admission into those courses in Nigeria, even though you are married. So that was the reason why I seated for JAMB 3 times. And in these 3 times that I wrote JAMB, I acknowledged that there were some topics that were constantly repeated. That is in 2020, 2021, and 2022. So I want to show you those topics in this video and how you can utilize them to pass the upcoming JAMB. So with these topics, you don't need to go and cover all the syllabus again. You just read them very well and pass your JAMB successfully. Now let us start. The first topic here is dimensions and units. And you know what dimension is? Other dimension we have fundamental quantities and derived quantities. And the standard fundamental quantities are length, time, and mass. It's very necessary to know them. And derived quantities are those ones obtained by simple combination of fundamental quantities. Here you will see questions like what is the unit of, in the option you may say which of the following have the same unit: A, work; B, force and work; C, force and energy; D, energy and power. Then by using the dimensional analysis, you will able to find out which one. Then the following topic here is motion. All you just know here, there is no much calculation. You just need to read motion, types of motion, such as random motion, oscillatory motion, circulatory motion, and translational motion. Know them very well, so that in your JAMB they may ask you the movement of smoke is what type of motion. Then you will able to tell them to choose the answer if it is random, circulatory, or oscillatory. Then the following topic here is work, energy, and power. So the most important thing here is to know work. What is work? Work is the product of force and distance, and under the influence of gravity, then that F will change to mg, and that S will change to h, which is mgh. And here is also energy. The most, we have different forms of energy, but the common one here is mechanical energy, which is divided into potential and kinetic energy. Under potential energy we have mgh, and kinetic energy we have half mv square. It's very necessary to know them and relate one to another. There's a situation whereby you can say mgh is equal to half mv square, and this power is work done over time taking. Under power, you may say that is work done over time taken. And what is work? Work is force times distance, and that distance over time taken will be velocity. Therefore, power will be force times velocity as well. So it's very necessary to know them. The fourth one here is heat energy. And you know what we call heat energy? There's what we call linear expansivity, cubic expansivity, and so many of them. For example, the formula for linear expansivity is change in length all over original length multiplied by temperature, where change in length is L2 minus L1, original L1 is L1, and temperature is theta. It's very necessary to know this one too. You will see many questions under this one. Then the following topic here is current, electricity. We talk of ohms, resistor in series and parallel. Here we talk of Ohm's law, which states that the current which passes through a metallic conductor is directly proportional to the what? To the potential difference. Therefore, you see V equal to IR as the formula there. And here we have resistors in parallel and resistors in series. We're talking about series resistor, R equal to R1 plus R2 plus R3. Then parallel is 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. So that is all you need to know in this place. And you should also know the amount of current or the voltage in the resistors in series. Does it vary? Also in resistors in parallel, what happened? So it's very necessary to know them. The sixth topic here is elasticity. We have Hooke's law, we have Young modulus, where elasticity says that When talking about elasticity, is the ability of a material to return back to its original shape after being distorted by external forces. And here we talk of Hooke's law, which states that provided the elastic limit of an elastic material is not exceeded, the tension is directly proportional to extension. Then by driving the formula, you have F equal to Ke, where F is the force, K is the constant, and E is the extension. Here you talk of Young modulus, which is a elastic stress over elastic strain, and stress is force over area, while strain is length over extension. So it's very necessary to know those one. Then we jump to the seventh topic, we have vectors and scalars. When talking about vectors, they have both magnitude and direction, but scalars have magnitude but no specified direction. Under vectors, we have velocity, displacement, acceleration. Other displays we have temperature, distance, and many more. So it's very necessary to learn and understand it. Then you have to know the algebraic, that is the representation of vector, where you have to use the knowledge of parallelogram or trigonometry to solve some simple problems there. Then jump to the 8 topics. Here we have machine. When talking about machine, the machine are the under is under mechanical energy. Machine is anything that make works easy for us, and we have things like mechanical advantage, mechanical disadvantage, velocity ratio here. For example, the formula for mechanical advantage is a load over effort, while that of velocity ratio is distance covered by effort over distance covered by load. But when talking about efficiency, is when you use when talking about a mechanical advantage, is when you use small effort to cover big load. Then we also have what we call efficiency. Efficiency of machine is mechanical advantage over velocity ratio, which is also load over effort times 1 over velocity ratio times 100. Then we have lever also. We have first class lever, second class lever, and third class lever. It's very necessary to read and understand them. Then when we jump to the ninth topics, we have Newton's law of motion. The other Newton's law of motion, we have first law of motion, second law of motion, and third law of motion. First law of motion says that every object will continue to be in a state of rest or uniform motion unless it is being acted upon by external forces. Then we talk of second law, it says that the rate of change in momentum is directly proportional to the applied force. Then we talk of the third law, which says that for every action there's equal and opposite reaction. For example, if you hit wall, you feel that you have hit something, even the wall will feel it. That's what they're talking about. Then here is momentum. There's this formula for momentum, which is MAUA plus MBUB equal to MAVA plus MBVB. That formula is very important to take note of it. Then when you jump, we have topic number 10, which is gas law. Here we have Boyle's law, Charles law, and general equation. For example, Boyle's law states that the volume of a given mass of gas is inversely proportional to pressure provided temperature remains constant, and you'll see a formula P1 V1 equal to P2 V2. Then when talking about Charles law, it says that the volume of a given mass of gas is directly proportional to its absolute temperature provided pressure remains constant, and you have P1 V1 over T1 equal to P2 V2 over T2. And the general gas equation states that that is the combination of Boyle's law and Charles law, and you have PV equal to nRT, or you have P1 V1 over T1 equal to P2 over T2. That's what you need to take note of here. When we jumped over to question the number 11 topics is wave motion. Terms used in describing wave. We have different types of wave. We have mechanical wave, electromagnetic wave, and we have properties of wave. We have reflection, refraction, diffraction, and interference, and so many of them. You should be able to know electromagnetic spectrum, and you should also know which one is a mechanical wave and which one is electromagnetic wave. Then when we jump further, we have heat energy. Other heat energy, we have temperature and measurement. What you need to know here is apparatus for measuring temperature. At the same time, you should know different types of thermometer, which that is different measuring apparatus. We have Fahrenheit, we have degree Celsius, we have a C's thermometer, and so many of them. Then I think that is all you need to know here. If we move further, we have reflection of light, and here it is very important to know the reflection of light formulae, which is 1 over u plus 1 over v equal to 1 over f, where that f is a focal length, u is the distance of the image, and v is the distance of the u is the distance of the object, and v is the distance of the image. Is very important. Then when you move further, you have sound waves. So all you need to know under sound wave is this. It's what we call vibration of any column, and you have to remember other sound wave. You see things like echo. It's very important to know the formula for calculating echo. At the same time, you should know the factors that affect sound. For example, it's also important to know where sound travel most. Is it in liquid, in solid, or in gas? So those are the important things you should take note of. Then there is this one, open pipe and closed pipe. They are also under sound wave. It's very good to know them and understand the formula for calculating those stuffs. It's also important to know amplitude, pitch, and them those things. When we move further, you'll see alternating current, which is AC, the capacitance of a capacitor. So here there's what we call capacitor. It have so many formula. For example, we have a Q equal to CV. From there, if you make C a subject formula, you get your capacitor, and so many of them. What do you even mean by capacitor? Capacitor is a material for storing charges, for storing electrical charges, and we have inductance. So read and understand them. The 16th here is electric field. Under electric field, you see things like this person. We have so many law. We have only one law under electric field, which is Coulomb's law, which is Q1 V1. Q1 Q2 over R squared. That is K Q1 Q2 over R squared. That is the law you should take note of. Another one here is magnetic field and EM induction machine. It's very important. The following topic is gravitational field. So here you have to know Newton's law of gravity. So you see laws like F equal to G m1 m2 over R squared, where m1 m2 are the two different masses, and G is the constant, which is 6.67 times 10 raised to the power minus 11, and the R is the distance between those two objects. Then the 19th is nuclear physics, which is radioactivity. When talking about radioactivity, it is the spontaneous disintegration of the nucleus of an atom, and when it disintegrates, it produces an alpha particle, beta particle, and gamma ray. You should also know the properties of those particles and those simple reactions, so that half-life and alpha reaction, this thing, nuclear fusion, nuclear fission. It is very important to know them. Then the 20th topic here is semiconductors. Under semiconductors, for example, if you go to group 4 elements in periodic table, we have carbon and silicon as semiconductor. What are their functions under transistors and diodes? It is very important to know them. So this is what I have for you for now, and if you find this video interesting, consider subscribing for our upcoming useful videos. Thanks for watching.